All right, the next class of compounds. These are called acid salts. So for acid salts, okay, you're looking at something that has, again, the hydrogen plus the anion name. Okay, if it has two hydrogens in an acid salt, you take the dihydrogen plus the anion name. Sometimes use of the prefix bi to indicate the presence of one H attached to an anion, like hydrogen carbonate or bicarbonate. That's why it has the name it does. The normal nomenclature is the hydrogen carbonate, but it is most commonly referred to as bicarbonate. And sodium bicarbonate is what is found in baking soda. HS, 1 minus, would be hydrogen sulfide or bisulfide. And then HSO4 minus 1 minus is hydrogen sulfate or bisulfate, is the nomenclature of these acid salts. Yes?
I don't know that salts. Aren't salts supposed to be neutral and like you all have charges?
Correct. So these are not neutral. They are called acid salts. They're a little bit different because they all have a charge on them. They include some hydrogens, but not all the hydrogens. So this one here, or I'll take this one, hydrogen sulfate. The reason this is called an acid salt is because the HSO4, this here actually could have came from H2SO4, which we know as an acid, sulfuric acid. So this is an acid. As it loses one of these H's, it becomes what is called an acid salt. Now, that means it has properties of an acid and properties of a salt, so to speak. If it went even further and you got SO4 2 minus, this here, without the H's in here, could actually be a salt. So this word salt is used to refer to things that are oftentimes neutral, but this is not quite there yet. It's like on the way to be there. So SO4 could be neutral, yes. Now, when we learn more about salts, we'll talk more about this middle point. Why is it called an acid salt? Okay? So salts you said are neutral. You're absolutely right. Salts are neutral. But here, this one has an extra H. This one has how many extra H's? 2. This actually is more acidic. This is a salt, and this is in between. So they call it an acid salt.
The neutral and hydrogen is not a charge.
Yeah. That would be one way of interpreting it, absolutely. And when we learn more about acids and bases, we'll learn that the amount of H's determines whether it's an acid or not. Now, HSO3, same thing. The name of it is hydrogen sulfite or bisulfite. Now, the last class of compounds, knowing how to name these are called hydrates. Most often, this is how ionic compounds are found in nature. These are ionic compounds that contain water molecules in a definite ratio as they crystallize. Should not be ratio. The trapped water molecules can be heated away from the compound. So the water molecules attach to this ionic compound, and if you heat it up, the water molecules can evaporate, and then you get what's called an anhydrous compound or an anhydride. Hydrate compounds that lose trapped water are called anhydrides. Now, how would these apply to our life and every day? You may not have a need for these necessarily, but if you're in the desert, you could store water in a solid form, in a hydrate, and you heat it up, and the water will come out, and the salt will stay behind, and you can actually get drinking water using chemical compounds. So it's one way to save your life if you're in the desert and you can't carry a bunch of water. You use a bunch of hydrates. Now, nomenclature rules for the anhydrides. First, you name the ionic compound. So sodium chloride, magnesium sulfate, whatever it is. Then you add the word hydrate with the prefix denoting the number of water molecules. A is used to form this little, looks like a multiplication symbol, a dot. is used to denote trapped water molecules. So you put a dot after the ion name, and then you write out how many water molecules there are. This is a picture representation of magnesium sulfate. That is a hydrate. So you notice there's 7 waters attached to 1 magnesium sulfate. That's how this particular hydrate is made. To name this, you would take the name magnesium sulfate, and then 7, the prefix for 7 is hepta, and then include hydrate, representing the water. So this is sodium thiosulfate pentahydrate. Think about how you would write this down. So here are ions, sodium and thiosulfate. Penta means 5, and hydrate means what? Water. So we start out with this. Now what do we have to do with the ionic compound? We have to make sure it's neutral. Then we include the hydrate symbol in the middle, saying the water is attached to the sodium thiosulfate. And this is the chemical structure of sodium thiosulfate at the molecular level. These all representing waters around the sodium thiosulfate. There are 2 sodiums, 1 thiosulfate ion, and 5 waters attached together. So at this time, I'd like you to name or write the formula for the following hydrates. James.